In today's video, we're going to explore the factors that influence the rate at which chemical reactions occur. These key factors include temperature, concentration or pressure, surface area, and the presence or absence of a catalyst. However, before diving into how each of these factors works, it is essential to understand the theory behind chemical reactions, known as collision theory. According to this theory, for particles to react with each other, they must collide with enough energy to overcome a certain threshold known as the activation energy. If the particles collide without reaching this minimum energy, they simply bounce off one another and do not result in a chemical change. In the context of an entire chemical reaction involving countless particles, the rate of reaction at any given moment depends mainly on two crucial things. First is the energy the particles possess, because the more energy they have, the more likely it is that their collisions will overcome the activation energy barrier. Second is the frequency of the collisions, which refers to how often the reacting particles actually bump into each other. Even though not every collision results in a successful reaction, increasing the number of collisions increases the chances that some of them will be successful. Whenever we consider how temperature, concentration or pressure, surface area, and catalysts affect reaction rates, it is helpful to always think about whether they are increasing the energy of the particles, the frequency of the collisions, or both, because either of these will lead to more successful collisions and hence a faster rate of reaction. Starting with temperature, when we raise the temperature of a reaction, the particles involved gain energy and begin to move more rapidly. As a result, not only do they collide more often, but the energy of each collision is also higher, which increases the chances of surpassing the activation energy. Therefore, higher temperature means more frequent and more energetic collisions, which both contribute to a higher reaction rate. Next, concentration and pressure are often grouped together as they both deal with the number of particles in a given space. Concentration generally applies to reactions involving solutions, while pressure refers to reactions involving gases. When either the concentration of a solution or the pressure of a gas is increased, there are more reactant particles in the same volume, so the particles are closer together and will collide more frequently, leading to an increased rate of reaction. Surface area is another factor that affects reaction rates. When a solid reactant is broken down into smaller pieces, its total surface area increases. For example, if we are reacting 3 grams of magnesium with hydrochloric acid, we could use a solid block of magnesium, small chunks, or fine magnesium powder. Even though all 3 forms have the same mass, the powder has a much higher surface area to volume ratio, allowing more area for the acid to react with at the same time. This increased surface area means more collisions can take place at once, which increases the frequency of collisions and therefore speeds up the reaction. Now, let us move on to catalysts, the final factor. Catalysts are substances that speed up the rate of a reaction without being consumed or permanently changed by the reaction. Since they are not reactants or products, we do not include them in the balanced chemical equations. To understand how catalysts work, we can refer to a reaction profile graph, which shows the energy changes during a chemical reaction. The peak of the curve on the graph represents the activation energy, the energy needed for the reaction to occur. A catalyst works by lowering this activation energy, offering an alternative reaction pathway that requires less energy. As a result, a greater proportion of the particles will have enough energy to react when they collide, which increases the number of successful collisions and speeds up the overall reaction. Catalysts come in many forms, and the term itself is very broad. Transition metals such as cobalt and nickel are often used as catalysts in industrial processes. In biology, you may recognize biological catalysts in the form of enzymes, which are special proteins produced by living organisms to accelerate biochemical reactions. In summary, the rate of a chemical reaction is influenced by multiple factors, and each of these works by either increasing the energy of the particles, increasing the number of collisions, or both. Understanding these factors allows us to control and optimize chemical processes, whether in laboratories, industry, or nature. That wraps up our discussion for today, and we hope you found it useful. Please like and subscribe if you enjoyed the video, and we will see you next time.